Coming up on This Week in Space, NASA's next chief weighs in on potential budget cuts. There's a great wall in space, and what's the deal with the Hubble Space Telescope 35 years later? We've got the original Hubble Hugger, John Grunsfeld himself, to tell us the skinny. Tune in.
Podcasts you love.
From people you trust.
This is Twit.
This is This Week in Space, episode number 158, recorded on April 25th, 2025, Hubble's 35th birthday. Hello and welcome to another episode of This Week in Space, the Hubble's Future Edition, among many other things. I'm Rod Pyle, of course, editor-in-chief at Astro Magazine, and I'm joined by my fellow non-mathematician, Tarek Malik, editor-in-chief at space.com. Hello, partner.
Hello, it's my birthday! Rod, hey, happy birthday. It's our special birthday episode for Hubble Space Telescope, but also me. So...
Wow, a way to be low-key.
No,
I forgot, or I would have made you another song. I think this is the first year I've gone without giving you something.
No, that's
Of course,
great.
you never return the favor, so that's
You
fair.
give me the gift of friendship.
I give you the gift of tolerance. Oh, there we go. The groupies weigh in. In a few minutes, we're going to be joined by Dr.
It's okay. You can.
I had a total blowout there. In a few minutes, we're going to be joined by Dr. John Grunsfeld, former NASA astronaut, former NASA chief scientist. He's got a whole list of qualifications that I'll read when he comes on. But perhaps most importantly, the guy who made, was it 5 house calls on the Hubble Space Telescope?
Three out of the 5.
Oh,
Three.
the 5 shuttle flights. That's right.
Yeah. So he's the Hubble Hugger.
Yeah. And Rod's the screw up the first act of the show. You should really do it again, guy. All right. Before we start, please don't forget to do us a solid. Make sure to like, subscribe, and the other good podcast things. We're counting on you to keep us popular and beloved. And now, a space joke from listener Paul Woolley.
Paul.
Are we going to have a sting for that? I guess not. Hey, Tarek.
Yes, Rod.
What do astronauts do right after landing on Mars?
I don't know. What do they do?
They post a selfie and wait 8 minutes for the likes to arrive.
But wouldn't it take 16 minutes? Because it would take 8 minutes to get to Earth and then 8 minutes to get back, right?
Yeah, picky. I know. I just didn't want to rewrite his joke. But yeah, and it also depends on the points of the orbit. It could be up to 40. But
I still dig it.
okay, let me try it again. They post a selfie and wait a while for the likes to arrive. How's that? Now, I've heard that some people want to fly on a repair mission when it's joke time on this show, but you can help and repair us by sending your best, worst, or most indifferent space joke to us at twit@twit.tv. All right, now that I've totally bollocks that, let's go to some headlines.
Headline news.
Headline news. Nailed it.
Now, on the tongues of many, as it should be, are the NASA budget cuts both across the board and specifically to the science budget. And we're going to be talking about that later on in this episode, as we have continually anyway. But also, no less than Jared Isaacman,
That's right,
future administrator of NASA, is not a fan of those cuts.
Yeah, I know. This came from Space News today. Jeff Faust over there has a great write-up that basically, we talked a bit in a past episode where Jared Isaacman had his Senate hearing for confirmation as NASA administrator. Now, those senators sent him questions back from that hearing that they wanted to know more, and included in them were questions about the proposed 50% budget cuts, which came after his hearing. And in fact, Senator Maria Cantwell of a Democrat from Washington asked him, pretty much straight out, if he supports the cut, according to Jeff Faust in Space News. And Isaacman is now on the record. He says he hasn't reviewed or been a party to those official discussions, but that a 50% reduction to NASA's science budget does not, and I quote, appear to be an optimal outcome. Like he doesn't think that it makes sense, and he said that if he is confirmed, he will advocate for strong investment in space science, astrophysics, earth science. He says as well, which is very interesting. When he was answering another question from another senator. So it seems like NASA's or the Trump administration's pick to lead NASA, and the proposed budgets that were leaked earlier aren't really on the same page currently, and it is something that we're gonna have to watch develop over time, because right now, like, he could face coming into an agency without having any agency over the actual budget, because the cuts would have been made by then. So
Right.
we're gonna have to
Probably
see
by
how this
design.
develops. Yeah, very possibly.
Yeah. That's unfortunate. All right. Next up, the next two are from space.com, because we love space.com. Quote, and
No bias at all. No.
This is remarkably unclickbaity for you. Largest structure in the universe is bigger and closer to Earth than we knew. Is it a threat?
The jury is still out on what it all means, is what the subhead is, not is it a threat. Oh my
I like
gosh.
that. Well, this might be helpful.
This one is from my colleague Rob Lee over at space.com. And I thought this was really fun because this was actually one of our most successful science stories of the week. And it is about the so-called Hercules Corona Borealis Great Wall, which I think is an awesome name for my band. If you guys can pre-order now, right? But it's this supercluster of galaxies that like line up in space into a filament of the web. So it's like some of the first galaxies in the universe, and it's crazy because it was first discovered about 11 years ago. 11 years ago, 2014. Is that 9 years ago? 9 years ago. Anyway, not 11
It's
years
11
ago.
years ago.
It is 11 years ago. I was right. So
Wow.
This is
Why we
I'm-
do news. Yeah. I love it.
I leave the math to the writers, though. It's
We're gonna
like
have some
10
editing
billion
of this
light years wide. It's like it covers an area like 10 billion light years by 7.2 billion light years. I mean, it's like a billion light years thick.
It's
It's
big.
absolutely crazy. It's huge,
Yeah.
huge thing. And what we discovered now is that it's even bigger than they thought. I mean, it's just they've been able to refine their observations with ground and space-based instruments out there, and now we know that they can use gamma ray bursts, which is how they did this. They looked for gamma ray bursts throughout the structure, and were able to piece that together through like distance calculations to see exactly how far away it is, how large it is, etc., to refine it. This absolutely blew my mind this week because I've been here 20 whatever plus years, and I guess I forgot that this thing even existed, let alone the fact that it was so massive and yet out there. So very interesting discovery, and we should go there. We should go to this Great Wall and go check it out, right?
Well, I think we should put that big space blob on Ozempic, but
It is.
More importantly-
it is a great wall you can see from space because it is in space, right? Does that?
sure
that's-
thing.
Okay.
Okay. Last but not least, China launches the Shenzhou 20 crew to the Tiangong space station, their newish modular space station, and that's a program that's going strong.
Yeah. This is from Mike Wall, our spaceflight editor over at space.com, and it was on was it Wednesday? It was on Wednesday, right? It was on April 24th. So it was Thursday, actually. They launched their latest mission. It's their 9th crewed flight to the Tiangong space station, which, if people don't know, is China's national space station. It is shaped like a giant T for Tarek, but also just because that's the easy way.
Oh my God. Oh my Lord.
But what's interesting though is that this really demonstrates that they have this crew rotation operations fairly well in hand. They're on a stretch of a series of uninterrupted missions, which I think is really interesting. And in fact, just last week, and I don't think we talked about this on the podcast, China inked an official agreement to train astronauts from Pakistan to fly to Tiangong. That's their first international astronaut agreement, and it could be one of many now that the International Space Station's days are numbered, that we know maybe by the end of the decade it could be re-entered. So just something definitely to watch over time, and we'll see if the space station grows, because they said that they're not going to rule out adding more modules to make an even larger space station over time.
All right. And very good. Thank you for that. And before we go to our first break and come back with Dr. Grunsfeld, I just wanted to tell people that my lovely 12-year-old Labrador mix, Charlie, went in for tumor surgery yesterday.
Oh,
and
Charlie.
Here's a picture of Charlie basking in the sun a few years back. He's a little younger then. So if everybody could send him good thoughts, because the surgery was bigger than we anticipated, and it kind of looks like he was the loser in a Saw the Lady in Half contest on a magic show somewhere. I mean, it's literally from his spine down to his stomach. So he's not a happy camper today.
Well, we're pulling for you, Charlie.
I appreciate that. And because it's Tarek's birthday, I have a little known fact about Tarek Malik to share.
What is this? What is this? What are you going to share to everyone? What dark skeletons from my closet?
Are you squirming in your briefs there, pal?
A little bit, Rod. It's always unpredictable.
I learned yesterday that Tarek Malik used to drive a Saturn LS.
That's right.
An LS, right? Yeah.
Yeah.
Which was kind of like, it was the Pontiac Aztec of its time. Somehow he thought that was a date magnet, and I just thought that was really fascinating. Oh, because it had a pointy nose, you said.
Yeah, it was very sleek. It was, it was named after a planet. I named it Molly. It was great. Now it's like a cube in a junkyard after being totaled on Hollywood Avenue way back when. So,
well, it's good to understand what a lonely man you were back in your youth. All right. So this is great. Let's go to a quick break, and we'll be right back with the rest of the show. Stand by. And we are back with Dr. John Grunsfeld. Let me read the list. Former NASA astronaut, former associate administrator of the NASA Science Mission Directorate, veteran of 5 shuttle flights, NASA chief scientist, former NASA chief scientist, former deputy director of the Space Telescope Science Institute, and a whole bunch of other things, with a PhD in physics and a list of awards and accomplishments that are truly humbling. Hello, John, and thanks for joining us today.
Hello.
Oh, my pleasure.
Oh, and I shouldn't forget, you're a member of a number of associations, including, which stuck out to me, the American Alpine Club, as well as the American Astronomical Society, AIAA, AAAS, and the Experimental Aircraft Association. So I guess the one there that sort of sticks up for those of us who are somewhat used to talking with the top-level people in the space trade is the American Alpine Club. What got you started in mountain climbing?
Well, I grew up in my very, impressionable years of the 1960s, and 2 interesting things happened. One of which, of course, was the start of the space program. I was born in 1958, so I'm a baby of NASA. But as I was growing up and very impressionable, I remember the Gemini flights. I used to have a little John Young Gemini lunchbox, metal lunchbox. But also, Americans started climbing in the big mountains with the Europeans and others. And through the pages of National Geographic, I got to see, people like Whitaker climbing Mount Everest. And I thought that would be cool. I grew up in Chicago, so not a lot of mountains there. But that always struck my fascination. And then around the 3rd grade, because I was asked to do a biography of Enrico Fermi, and I was so disappointed I didn't get somebody famous. But it changed my life in a way. And Enrico Fermi, of course, the famous physicist who fled fascist Italy to the U.S., helped develop the first self-sustaining atomic pile at the University of Chicago. And in fact, it was only maybe a mile away from my house. We were in urban renewal housing on the south side of Chicago. And so I could ride my bike over to where Fermi built that. But more importantly, he loved mountaineering. And he wrote about how he missed the Dolomites, where he climbed as a postdoc. And so in a way, I've kind of tried to model my life of physics, cosmic ray physics, and personal life. But I love to climb mountains. And so I joined the American Alpine Club many years ago.
So we have a vaguely similar origin story, but our lives took extremely different directions. But I do have to ask, since we were born within about a year of each other, did you have Major Matt Mason toys?
No, I did not.
Really? Oh, that was Mattel's Man in Space. That was my inspiration, although it didn't get me a doctorate in physics. Okay, Tarek, you're out. Sorry.
Thank you again, John, for joining us today. Especially today, as we're recording it, it's Hubble Deployment Day, right? The anniversary. 35 years ago today, as we're recording it, the Hubble Space Telescope was released into the void to then open its eye on the cosmos, and of course, the rest is history. But I'm curious how you got to where you are. Now, John. I mean, if the that path to an astronaut to physics was something that. It sounds like you're talking about Enrico Fermi, that it was there at the get-go, but was the space angle in all of this there at the same time because of that Gemini interest, the space program that was going on back then, or was that something that came up through your studies, becoming a physicist, et cetera?
Well, I have absolutely no doubt that the influence of the early space program put me on the path to become an astronaut. We lived close to an A&P grocery store. I don't even think they exist anymore. And so I would see the big trucks come back and, back into the space, and they would unload the trucks. And so as a young kid, I wanted to be a, commercial truck driver. And at about the age of 6 or 7, having seen, the space launches and the ticker tape parades, I declared to my mother I wanted to be an astronaut, and she thought that was actually great because it would encourage my nascent interest in science. This is before Enrico Fermi, and there's zero chance I would ever actually become an astronaut. So she didn't have to worry about, blowing up on a rocket. So I certainly fooled her. But that background interest in space, I followed Gemini, I followed Apollo, Skylab. And of course, the early space shuttle program, as I was exploring my interest in science. And I love, all kinds of natural science, but in particular, looking up at the stars and wondering, what's out there was sort of the highest priority. And that's what drove me in physics, in astrophysics, eventually going to college and studying physics and becoming an experimentalist. I built instruments that went up on high altitude balloons, and then continued that in my graduate studies. At the University of Chicago, I had a balloon experiment that I was working on, but also we had the Chicago Cosmic Ray Nuclei experiment that flew in 1985 on Space Shuttle Challenger. And my PhD thesis was actually derived from that shuttle flight. Now, of course, that's the year before the tragic loss of Challenger in 1986. But as I was going through elementary school, up through high school, I just assumed that by the time I was an adult, by the time I was a practicing astrophysicist, that all astronomers would go to space, right? It seems like the natural thing. And at that time, that was kind of the rhetoric, that space by the, 1990s would become routine. So it wasn't until I had my PhD that I applied to NASA the first time for the space shuttle program. And, I thought, okay, well, if I want to be an astronaut, this is how you do it. And I filled out the application, sent it in, thinking, okay, we'll see what happens. And months later, I got a call from Dwayne Ross at the Johnson Space Center. He was the head of the astronaut selection office. And he said, "Hey, John, are you still interested in becoming an astronaut?" And I was sitting at my desk at Caltech at the time. And I said, "Well, of course." And he said, "Well, we'd like you to come down for an interview." And I said, "Sure." And I assumed they must interview thousands of people. And I arrived and there were 12 people in my interview group. And I had no clue what was going on, what the protocol was, what I should prepare for. But I did well. And I was told that they interviewed a bunch of scientists and that they picked 2. And they picked Jim Newman and Tom Jones for the class of 1990. And I was ranked number 3, and they encouraged me to reapply, which I did. And so in 1992, I was selected into the astronaut candidate program, and then a year later graduated.
So that is really interesting because I knew that you joined in 1992, but now you're saying you applied in 1990, which is when Hubble launched there. So
Yep.
you're in an interesting spot because you were on the science side before becoming an astronaut as Hubble launched into space and had, we're going to talk a little bit about that relationship too in a bit, and then you became an astronaut and later on ended up working on that. So I find that split of being a scientist first with this instrument that everyone was excited about at that point in time, and then giving you a really unique perspective when you get your hands on the telescope itself. But we should ask about the Hubble Space Telescope now, because that is the soup du jour. It's why we hope to talk to you. I'm really curious about that relationship with Hubble. Like what does it mean to you now? 35 years later, and or Rob, do you want to go to a break first, or should we?
Why don't we go ahead and take a quick break?
We'll take-
Because I think this is going to be a really juicy answer.
Oh, I'm going to get carried away. So
Well, I will tell you that, when people ask, when did you start training to repair the Hubble Space Telescope? My pithy answer is at birth. With that, we can go to break.
Okay. We'll be right back, everybody. Stand by.
Great. All right. Okay. Now I'm ready. So, John, thank you for kind of setting the stage with your career there, so that people, are aware of your, I guess your ever burning light of for science there that led you to NASA. But your story really unfolded at the same time as Hubble, because we just talked about earlier. You applied the same year that Hubble launched. You were, I think, you were at Caltech in 1990 at that point in time, studying. When we spoke earlier this week, you said gamma ray and X-ray astronomy, right? As well.
So I was studying black holes and neutron stars, and in particular, black holes and or neutron stars that are in a binary system. So there's a large, massive star, and next to it is a compact object, a black hole or a neutron star, and the black hole is sucking up the other star until something happens.
Oh, that stuff is great. That is great. So were you and other astronomers excited? Like, I mean, we obviously now looking back, Hubble has become this icon of astronomy. But in 1990, when it launched, it had problems, but there was a lot of run up. Were you in the science community excited about that, and then crestfallen, or did you always expect it to be, I guess, the powerhouse that it's become?
Well, to put that in perspective, Lyman Spitzer, I think it was 1946, before we'd successfully launched, and anybody had ever launched anything into orbit, predicted that and suggested that we should pursue a space telescope that would orbit the Earth to get above the atmosphere so that it could see more clearly, so it could see ultraviolet light. And so the buildup from there through the dawn of the space age, the 1970s, when the Large Space Telescope was, seriously proposed and started being developed, to the Hubble Space Telescope, the astronomical community was really excited about it. The first of the great observatories. Of course, there are lots of different types of astronomers. There are astronomers who use ground-based facilities to look in optical and infrared. There are radio astronomers who use large dishes to look up at the sky. There were people like myself who were doing X-ray astronomy and gamma ray astronomy. And Hubble was sort of taking all the attention leading up to launch. And so there are a number of us, and myself included, that were, I would use, we're humans most of the time, unless we're Vulcan. We were a little bit jealous of all the attention and the funding that was going to Hubble. Of course, we had the Compton Gamma Ray Observatory, which is what I was using for my work, and the Chandra X-ray Observatory and the Spitzer Infrared Observatory, the other great observatories in process. But honestly, when I was selected as an astronaut, I was not a true Hubble hugger at that time. I appreciated its significance. And then, of course, it launched in 1990. It was deployed, today, 35 years ago. And it almost wasn't successful, but then we found out about spherical aberration. And so I'll just say that, 35 years ago today, the crew on Discovery, were really sweating bullets because one of the solar arrays didn't deploy. In fact, Kathy Thornton and Bruce McCandless during deployment were in their spacesuits in the airlock, ready to go if they needed to manually crank out the solar arrays. But fortunately, the ground was able to uplink a command to override and inhibit, and they were able to roll out the solar arrays and deploy Hubble. So we don't have a lot of pictures of the Hubble deployment because all the people to take pictures were, in the airlock with the hatch closed. So that was maybe the first Hubble save was on deployment day.
Wow.
So I had a list in here at one point, although I don't see it now, of how many hours you spent on EVA with Hubble over various flights, but it must have been between 25 and 30.
So I did 8 spacewalks between 6.5 hours and 8 hours and 40 minutes for a total of a little over 58 hours.
Yeah, we should point out. John is the self-described. You said it earlier, a Hubble hugger. You flew through 3 of the 5. How many numbers am I holding up? 3 of the 5 servicing flights there, and including STS-125, which was my last, my first, and I guess last Hubble servicing mission as a space reporter there. But no, what is it? No spring chicken to servicing the Hubble spacecraft. I think that's what, Rod, you were going to get at there, right?
Well, where I was going to go is, John, I've written a lot about the early space program, Gemini through Apollo and so forth. And one story that always really intrigued me was the struggle to get EVA right. So you talk about those early to mid Gemini flights where they were just doing stand-up EVAs and floating free a bit from the cockpit. And then they started climbing out to the Agena, which was the attached spacecraft to the front of the Gemini that it docked with to retrieve experiments. And then finally getting from the door of the hatch of the Gemini capsule to the back of the trunk there, where they had a busy box thing. It took multiple missions, and it really wasn't until Buzz Aldrin went up. He had trained, one of the few to really train extensively in neutral buoyancy and water, and made it work. But it's a great lesson and description of why it's not easy to do EVAs. So even though there have been a couple of decades by the time you came along to work on Hubble, I'd be interested in hearing how challenging it is, because you train a lot in the neutral buoyancy tank, but then you get up there, it's a whole different environment. Now you're looking at the real thing. How challenging is that? What are some of those challenges?
Well, first of all, I think the Gemini program is vastly underappreciated. Mm-hmm. When you look at going from a Mercury flight, sitting in a capsule, orbiting the Earth, and entering, that's world changing. But when we started Project Apollo, we were planning to land on the moon and walk around in spacesuits. And we didn't know how to do rendezvous. We didn't know how to do docking. We didn't know how to do spacewalks. We didn't know how long people could live in space, if they'd even survive a trip to the moon and back. And Gemini proved all of those things in a very short period of time. Mm-hmm. So Gemini was really invented between Mercury and Apollo to prove those things out. And indeed, spacewalking proved to be one of the most difficult. Because you're in this pressurized suit, you're like the Michelin man, and it takes physical effort, for the physicist out there, the integral of F dx, just to move in the suit, to open and close your hands. And so of course, we did land on the moon, we walked on the moon, but the shuttle program is really where we refined the spacesuits so that they worked well. And so that they could fit lots of different people, and especially the gloves. The Apollo astronauts complained about the gloves, and we worked many generations of gloves for the space shuttle program. But a lot of it comes down to what you said: training, and more training. For the Hubble flights that I was on, we did 3 spacewalks the first mission, but we were training for a bigger mission that would do 6 in a row, 6 day after day.
Wow.
It was decided by management and probably correctly that 5 was probably the max we should do. And so on my second and third Hubble missions, we had 5 spacewalks, so I did 3 on each mission. Roughly speaking, for every hour doing a spacewalk, we trained about 12 hours in the pool. But that doesn't include all the engineering work where we developed the procedures for the spacewalks or the tools or the techniques. So it's probably more like 15 to 20 hours for every hour in space. On top of that is the basic spacesuit training that we do in the pool, for fixing the space shuttle in case that breaks. I've done, I can't remember how many spacewalk practicing to fix the space station and develop that, because that was being co-developed while I was flying the other missions. So much so that when I go out on a spacewalk in the shuttle spacesuit, I'm just really comfortable. I mean, it's just a very different experience than the Apollo astronauts. So much so that there were times where I sort of marveled, it startled me that, where I was working with sub-miniature assembly connectors on a radio frequency transmitter receiver, I thought, I feel like I'm in shirt sleeves. I'm so, doing this, and it's so familiar that I forgot that I was in a spacesuit. Not quite, but I felt that way.
That's really amazing. I do have a follow-up, but let's run to a quick break. We'll be right back. Stand by. As I understand it, then, besides the training and everything, the actual replacement bits for the Hubble, the things you were upgrading and servicing, were mostly modular, but I assume, like so many things technological, that doesn't always work out quite as modular as you'd hope in terms of replacements and so forth.
Yep. The brilliance of Hubble is that it was designed to be, serviceable, almost everything. And it was co-developed with the shuttle. It was designed to be to fit completely in the payload bay. It was as big as it could be. If it were any bigger, it would have been stuck. And as well, it was designed with doors that open and close. You can kind of see it on the picture behind me. And the avionics and the scientific instruments were modular, such that with some bolts, you could unbolt them and take them out. Connectors, put them back in. There were some things that they thought it'll never fail. But also, just because of technology developments and learning how to operate the observatory, there were things we decided to do. And this is the amazing community, the Goddard Space Flight Center, the contractors, the scientists, that were never anticipated that we would do. So one example of something that they said would never break was the S-band single access transmitter. And so this is something that's very important for talking to the comm satellites at GEO. And one of them failed. If a second one failed, it would significantly impair the Hubble. So it was decided to go fix it. And this is just a little box about this big with all, transistors and power transistors and radio frequency connections. And the antenna wires are coaxial lines with these little sub-miniature assembly connectors. And it was screwed in with screws that you can't just put a wrench straight on. And of course, they were non-captive. So if you take them out, they would float away. Yeah. So we had to develop tools to, get under the overhanging lip to get into where the screwdriver fits, and a special tool to hold on to the screw after it comes out so it doesn't float away and get into the Hubble optics or somewhere. And then I had to train myself with my fingers to not over torque those little sub-miniature assembly connectors. And then I had a tiny little torque wrench that was set at about 8 inch ounces to do the final torquing.
Inch ounces? I've never even heard of that.
And the fun thing is that I would go to the local hardware store and buy tools and modify them in my home shop and go into the pool and we'd try them out. And then, a month later, Goddard would have made an official tool. And so we evolved those tools during training so that, again, I could do that task. And one of my questions is, because often when you screw something into Hubble, you put a little something like Loctite so that the screw won't back out during launch. And I said, are those screws, glued in, or are they just tightened to a torque? And they tried to find the documentation. They said, well, we think it's just screwed in. You won't have to worry. And of course, I got up there and, I couldn't turn the screws. I ended up having to use both hands and turn a tiny little screwdriver because, in fact, they were glued in.
Wow.
But that's an example of, one of the tasks that wasn't anticipated before launch. Other things, the NICMOS cryocooler, the near-infrared camera multi-object spectrograph, had a cooling system failure. And so we went up in 2002 and installed a big radiator on the outside of the telescope. And Rick Linehan and I replumbed a cooling system into a hole in the bottom of the telescope and plugged it into the NICMOS. So, not only was I an RF technician, avionics technician on Hubble, I was a plumber. And then we also did a bunch of re-electrical wiring of the solar arrays to the power units. And so we're electricians. And then, of course, just mechanical engineers taking big instruments in and out. But there were a lot of repairs we did that were not anticipated. And in a way, those were some of the most fun, and because they were challenging.
Well, I did want to ask about just the whole concept of that. Of course, these spacewalks are integral to the repairs, to the upgrades for Hubble. But why even want to build that capability into an instrument like the Hubble Space Telescope in the first place? Because it was launched in 1990s. It was developed over the decade or so prior to that. That's all state-of-the-art technology. Hey, that's great. The Voyager spacecraft are doing fine, relatively speaking, 40 plus years, out in interstellar space. But why build that capability as both a scientist and an astronaut, from your view, into this instrument?
Sure.
In the first place, we've got James Webb. It doesn't have that capability, and people seem to be happy with it.
So a couple of things. One of which is that it was recognized before launch that the instruments that were available in the 1980s would quickly be overcome by new developments in astronomy. Astronomers, astrophysicists, scientists in general, to make measurements, to unravel the mysteries of the universe, are always pushing technology. Mm-hmm. And nowhere is that more true than in astrophysics for ground-based observatories and space-based observatories, where, we push semiconductor research and detector research and electronics to get more performance, to try and look further into the universe or in higher spectral resolution, where you break the light up into its component colors and look for, the signature of various physical phenomena, or something like LIGO, where we're measuring the distance between mirrors at a fraction of the diameter of a hydrogen atom in order to look for gravitational waves. In fact, that's one of the reasons why our country does this kind of breakthrough science, is that it pushes technology to force people to invent new things, which then companies can take advantage of to improve the economy, our national defense, human health. In fact, the technology that we're using for this podcast, the video, is based on first charge couple devices, silicon cameras, which when Hubble was launched were virtually non-existent, and then now CMOS sensors, all of which were developed and pushed by astronomers and then became, mass market items. There was no camera in a phone when Hubble was launched. And so the need to change instruments out on Hubble periodically was really the crucial thing. Mm-hmm. Because each time you bring up a new generation of scientific instruments, it's like having a brand new observatory. And that's one of the great things. Hubble now, after 35 years, because of the 5 servicing missions, has a complete set of scientific instruments, which are, for the most part, state-of-the-art still today.
Yeah. Wow. I'm curious. That kind of leads us to our next question, which is just the science behind it all. You and I had a nice long interview earlier this week where you talked about like some of your picks, but for the benefit of our listeners and viewers here, I am curious if there's we'll we'll have to go to a break first. But I am curious that like if you have 5 or 3 like key ones. But let's go to a break really quickly, and then we'll come back and
because we want the whole answer. Yeah.
Okay, I think we're ready now. So yeah, because we talked a lot about the spacewalk, and that prowess, that engineering accomplishments of Hubble. But what about the science that it's allowed? Because the images are undeniable, right? But there's much more to just the pretty pictures for Hubble. Is that right?
Yep. Oh, absolutely. So first of all, Hubble was designed originally for a 15-year lifetime. And in that 15 years with servicing, its sort of high-level requirement was to measure the expansion of the universe in order to get an age estimate of how long our universe has been around since the Big Bang. And it was hoped that Hubble could see maybe halfway to the origin of the universe, 6 or 7 billion years back in history. So keep in mind that the universe is very vast and light travels at a finite speed, the speed of light. And so it takes time for when light is emitted, say, by a star in a distant galaxy to get to Earth. And so when we look with Hubble and do a big long time exposure, we're seen back into history, cosmic history. And so Hubble did that measurement. It measured the distance to distant galaxies. But because it's lived for 35 years, we've not only been able to measure that age of the universe and the expansion of the universe back to half the age of the universe, which, by the way, is about 13.8 billion years old. We've actually been able to see back to about 13.2 billion years with Hubble, almost all the way back to the beginning of stars and galaxies themselves. Now, James Webb can go even further because of the cosmological redshift. Eventually, Hubble could see further, but it's not an infrared telescope, and the light from back then is ultraviolet light emitted back then is now infrared light by the time it reaches us, just because the light waves get stretched out as the universe expands. So we measured the age of the universe very accurately, and one of the things that we didn't expect when Hubble was launched, because nobody thought of it as a possibility. Well, maybe Einstein did. But as astronomers looked at these distant galaxies and measured the rate of expansion over cosmic time, instead of seeing something where the universe is is either expanding constantly at the same rate, or because of gravity pulling on everything, the universe could be expanding and slowing down. Adam Rees at Johns Hopkins University and Space Telescope Science Institute, was making those measurements, and in his notebook found that the universe looked like it was accelerating. And he had like a question mark in there, like, there must be something wrong with the measurement. And made more observations, and as the data came in, it became more and more certain that, in fact, starting about 6 billion years ago or so, this expansion force, this mysterious dark energy force, started taking over, and the universe has been accelerating. And of course, that led to Adam Rees, Brian Schmidt, and Saul Perlmutter winning the 2011 Nobel Prize in Physics for that discovery. And I like it that Adam says, no Hubble servicing, no Nobel. Because we put in the advanced camera for surveys in 2002 that allowed him to confirm that measurement.
Wow.
That's kind of the update of No Bucks, No Buck Rogers, right?
Yep,
and
that's
that
right.
reminds me, I feel like I'm grossly oversimplifying things, but anybody who's been a NASA watcher for decades knows it's been a struggle to keep the sale going with the American public, which is a shame, because it's not an expensive agency as things go, and the returns are just so vast, even just raw financial returns. I'm sure you've seen the numbers, for the Apollo program, for every dollar that went in, 16 to 26 came out. But Hubble kind of turned that on its head, because regardless of how how valuable the science has been, and it's been fantastic. The visuals have been breathtaking, as has been said over and over and over, mostly by NASA insiders. It's the gift that keeps giving. So the messages that people involved with Hubble, like yourself, have been able to send the public are, look, this isn't just interesting and cool abstract science. It's beautiful in a way that connects you with the universe that nothing else can.
Yep. Well, absolutely, NASA is popular for good reason. First, from a practical point of view, NASA scientists, engineers, the missions that NASA does. NASA is a mission agency. We perform these amazing missions. To do those missions, we have to invent new things. I like to say that the mission of NASA, in a way, is to innovate, to create new things, to go out and explore. And when we explore, we discover things. And when we discover things and communicate it to the public, we inspire, a nation and a world. And Hubble is one of the best exemplars of that. If you go around the country and you see, you go to a national park, there are people wearing, NASA meatball shirts. And in fact, that's true around the world. That's aliens calling.
I love that. That's the ringtone. That's awesome.
But all around the world, you see NASA shirts. And as Associate Administrator for Science, I would travel around to different countries, giving astronaut talks, giving science talks, meeting with scientists in those countries. And, the U.S. ambassadors around the world say that NASA is the best ambassador of the U.S. of any of the, federal programs. And I think that's pretty meaningful, because as far as U.S. leadership, as far as U.S. greatness, NASA is really at the top of the list. NASA is popular on both sides of the aisle in Congress, partly because NASA is all across the nation. And when you ask Americans, do you like NASA? Almost universally, people say yes. And then when you dig in and you say, well, what do you like about NASA? As people start listing things that they know about, there's the original moon landing, that's often mentioned. But then it's Hubble. It's, Mars Curiosity, Mars Perseverance, the Ingenuity helicopter, James Webb Space Telescope, missions out, to the edge of the solar system. And it's not until 8 or 9 do people start talking about, the human spaceflight program. And only about half of Americans know that we even have an international space station with U.S. astronauts on board. And so the science missions really do generate that wonder and awe and inspiration in the American people that make NASA so popular, which, makes me rather befuddled that the talk now is about, slashing, really an epic slash in the science program at NASA, and cuts to human spaceflight as well. If it's about economic superiority, if you will, investing in NASA, as you say, currently the analysis shows that every dollar invested in NASA is about $7 to $9 in GDP. And so if you really wanted to enhance the economy, you would invest more in NASA, not less.
Yeah, we should point out that. Oh, go ahead, Rod. Go ahead.
I just want to mention two things real quick. As part of that public perception question, as I'm sure you've seen the same polls I have, they change from year to year. But generally, if you ask the average American citizen, hey, what percentage of the federal budget is NASA? They go, 10%, 20%. You're thinking we'd have condos on the rings of Saturn by now if that was the case. So I know that NASA's overall budget is roughly half of 1%. But what is the science budget in terms of the federal budget? It's tiny, right?
It's tiny. If you could make some big agency, say the Defense Department, if you went to the Pentagon and said, hey, we'd like you to be 1% more efficient, that would pay for most of the science that the U.S. invests in, across all agencies.
Well, so you touched on it. So thank you for grabbing that third rail for us. As listeners of the show know, the regular ones, the science budget at NASA it's been proposed that it be cut by 50%, and a significant percentage of those are in astronomy, astrophysics, and of course Earth science. It's been represented as everything, depending on which organization's press release you're looking at, as a criminal act to, just extreme thinking. I think our view on the show is, look, we understand you may have to make some trims, but not to this level, and certainly don't slash major programs like the Roman Space Telescope, which is already built,
which is already
and ready
built
to go.
Yeah.
And there's others in a similar situation. So I imagine you have some thoughts about this, and I'd love to hear them.
Well, I think it's nearly insane to cut the NASA science budget because, one, Americans love NASA science, and they're the taxpayers.
Mm-hmm.
They are paying taxes to get a return, but it's also more about the investment that the U.S. makes in science, and you can sort of reflect back on America basically winning World War II for peace in the world, and coming out of that, the U.S. put a study together led by Vannevar Bush to say, how can we take advantage of the science, the engineering that we put into, the tools that allowed us to win World War II, to take advantage of, scientists and engineers working for the benefit of the U.S. economy, for human health, for national defense. And out of that came organizations like the National Science Foundation, NACA, and then NASA, DARPA, and all of the effort that we put into, and of course for human health, the Centers for Disease Control and all of Health and Human Services research programs. And that's why we are lead the world in so many areas, in astrophysics, and in fact, in almost all areas of space science. The U.S. has, complete dominance, working with other countries, working with the European Space Agency, working with the Japanese Space Agency, Canadian Space Agency, scientists around the world. But we lead the world in space science, and in particular in astrophysics. And these cuts we're just handing the leadership over to other countries, and specifically China, which has been working very hard to build their space science program up, and specifically astrophysics. They are working on something like a Hubble, a servicing observatory to be near their space station. And so it just seems crazy. Now, specifically, Hubble, James Webb, Roman, and the next great observatory, Habitable Worlds Observatory, these are really important programs for leadership in the U.S., but also because when astronomers push the boundaries, as we are with these telescopes, it's a great benefit to national defense. We're not the only ones who use telescopes, as you can imagine. In the example of the Roman Space Telescope, I was associate administrator when Department of Defense approached us and said, hey, we have a surplus optical system. Do you think this could be valuable to NASA? And I looked at the details and said, oh, absolutely. If you're not going to fly it, we have a mission that can take advantage of this. And so as far as government efficiency, there's nothing more efficient than reuse of something that taxpayers have already invested in. And that's how we took the WFIRST, the Wide Field Infrared Space Telescope concept that was recommended by the National Academy of Sciences Astrophysics Decadal. We took that concept, married it with this optics, and now we have almost ready to go to the launch pad, a complete observatory with instruments, and with a particular instrument called a coronagraph that's a technology pathfinder that can image planets around nearby stars to look for if there's life in the universe beyond Earth. Is there another Earth out there? And the idea that we'll just willy-nilly cancel that for reasons that are not clear really, to me, seems somewhat insane. Now, to be fair, the reports and all of my knowledge come from public domain sources. This is a proposal by Office of Management and Budget to NASA for, slashing and burning NASA. Hopefully, Janet Petro and the leadership at NASA can push back on that so that the final budget that the president announces, will have broader support for NASA, not throwing it down the toilet the way it seems like they're thinking.
This sounds like a...
I want to stand up and cheer here.
But also there's two things I'd like to add to that. One of which is, we do have a U.S. Constitution, and if you'll bear with me a second, maybe after the break. I keep one on my desk, which is eluding me at the moment. But yes, of course, because it's sitting out. I wish I could remember who gave this to me, but a congressman gave this to me, and I carry it around with me. It's been to Antarctica, as a matter of fact. But the Constitution says that the Congress has the power of the purse. So the president's budget request is exactly that. It's a proposal. It's a request for Congress to consider it. And widely in Congress, NASA's appreciated. However, this is a weird time, so it's not clear what will happen. But, Congress could rescue us. Unfortunately, the Office of Management and Budget, as I learned in my 5 years at NASA headquarters, they have a lot of authority to direct agencies, independent agencies like NASA, to start making severe cuts even before Congress enacts a budget when you're in a continuing resolution, which seems like we're always in a continuing resolution. And so a lot of the cuts are happening now. People are being offered buyouts. People are being laid off in a reduction in force. And Hubble and James Webb are not being spared.
Yeah.
My understanding is that NASA's been directed already to start turning off instruments and laying off the engineers and scientists who support Hubble in order to save a few tens of millions of dollars.
If that, yeah.
And that's just crazy.
Yeah. For our listeners who may not have seen, when I was at the American Astronomical Society meeting, that's where during the town halls we were told that it was a blanket 20% cuts for Hubble, for James Webb, for a lot of other programs, just to be ready to have a plan for that kind of thing. And it's a good time, Rod, we should remind people that, as John reminded us with Congress having the power of the purse, people put them there, right? And if NASA science matters to you, you can call your congressman and tell them that so that they hear from you, hopefully every day. Maybe just call them every day.
In fact, I would say it's a civic obligation. You must call your congressman, write your congressman, and tell them what you think, whether you're in favor of, the U.S. being leaders of the world in great science or not. Hopefully you're in favor of that. You're watching this podcast. But if they don't hear from you, they don't know. And they make decisions based on what their constituents, people like you, tell them is important. And I think, NASA science and NASA in general is one of the best things that the United States does with taxpayer funds.
And it's a gift that we've been giving to the world since the beginning of the agency, which is something that I think is underappreciated, which is one of the reasons why we send a copy of every quarterly publication of Ad Astra magazine, which I edit, to all the members of Congress at significant expense to make sure that they at least give it to their aides to read during their bathroom breaks, because these things are important. And like John says, if you don't call, they don't know, and they need to know. Sorry, Tarek, I jumped in front of you there.
No, I thought, because this seemed like a really good time to start talking about the future as well. John, you mentioned successors to Hubble with we talked a bit about the Roman Space Telescope, but you mentioned the Habitable Worlds Observatory, which you actually presented a study at AAS about having robotic servicing capabilities for that mission. And I'm curious what the future of space-based servicing telescopes looks like to you, and then maybe how much maybe more time we'll get out of the Hubble Space Telescope as well.
Sure. Well, let's rewind the movie a little bit to 2004. In 2003, we had the tragic loss of Space Shuttle Columbia. And as a result, then NASA Administrator Sean O'Keefe made the decision that we would not go back to Hubble. And it was based on an overall risk assessment that if a shuttle got stranded at Hubble, you couldn't hang out for Hubble for 6 months the way you can on the space station. And as Sonny Williams and Butch Wilmore discovered even longer, that we wouldn't do that mission.
Yeah.
At the time, I was NASA chief scientist. And so I came up with the idea of, well, what about a robotic servicing of Hubble? And we actually showed that you could do not the complex things that we had done on Hubble with the space shuttle and spacewalks, but you could remove a big instrument like the wide field camera and put in a new wide field camera using a simple robot. Now, once we had return to flight figured out and a few other things, Administrator Mike Griffin decided we would go back to Hubble, that if we're going to fly the space shuttle, we should do really important things with it. And Hubble servicing was one of those. And, I was glad because he asked me to go back. So in 2009, we did a really major upgrade and repair mission on STS-125, such that Hubble is still operating today, 16 years later. And in fact, the prediction is that Hubble, absent any major failure, you never know, should be able to continue to do state-of-the-art forefront science for another 10 years.
Wow.
Which would be amazing. Now, by that time, Hubble will be 45 years old. And so NASA is starting work already, concept studies for a super Hubble. And this will be the first observatory that's ever been conceived of and built specifically to look out into the cosmos, actually to look at nearby stars, to image solar systems, to look for rocky planets that have signs of life. So there'll be sun-like stars, and hopefully we can find a rocky planet in the habitable zone and then study that to see if we see any signs of life on it. The current thinking is it will be about a 6-meter mirror. Hubble's is 2.4 meters. And it will go to the same orbit as James Webb, 1 million miles from Earth, to get away from all the disturbances around the Earth. But that makes it harder to service. And why would we want to service it? Same reason as Hubble. The instruments that we'll launch with will be state-of-the-art at launch, but 5 years after that, they won't be quite as capable as what we could build. And this trick of, blocking out the starlight from a sun-like star and seeing planets around it is really, really hard. And so we're going to be able to get better at that over time. The Roman Space Telescope will give us a lot of information about the performance of a coronagraph in space. That's the special instrument. The first generation Habitable Worlds Observatory, as it's called, will give us more information, but it's probably going to be the second generation coronagraph that will really find us those Earths and the ability to see if there's life there. To do that, you'll have to swap them out. And so 1 million miles from Earth is not a great place to send humans. But by 2045, say, we should have very capable servicing robots that we can hire as a commercial service to deliver the instrument, swap them out, and then send the observatory back on its way. And so that's what we're thinking. My mantra for this effort is make it so easy, even a robot can do it.
That's fantastic.
As usual, we still have questions left, but we're running out of time, so I hope we can have you back at some point. That would be a delight. But I want to thank you very much, John, for coming on today for episode 158, where we got to talk about all kinds of cool stuff, but especially one of our perennial favorites, the Hubble Space Telescope. So for our listeners, viewers, you can keep up with the latest on Hubble and other things at stsci.edu, which is the Space Telescope Science Institute. John, is there some place we can keep track of you and your climbing adventures and so forth online?
I don't have a website, but I do want to say if you go to science.nasa.gov/missions/Hubble, that's another great place to go. That's kind of the current Hubble Central, as NASA has been directed to consolidate all of its websites. So again, that's science.nasa.gov/missions/Hubble. Or if you go to science.nasa.gov, you'll see all of the missions, which is a good thing to do. And I'd be remiss if I didn't say one more time, write your Congress folks, write your House of Representatives representative, write the Senate, and you can go to whitehouse.gov and, every American citizen can give President Trump their input.
You beat me to the punch. I was going to say all together now, write your representative. All right, Tarek, where can we find you writing your representative these days?
Well, you can find me at space.com as always, and on what is it? On the X, I guess, at Tarek J. Malik, and Blue Sky as well. That's me. And I guess this weekend we'll be at the Pinewood Derby, hoping that we have the most aerodynamic car. We'll see how my daughter fares in her Girl Scout meet, and having some cake because I'm 48 today, and so that's really exciting.
Well, I hope you did the computational fluid dynamics to demonstrate the aerodynamics of the car.
Way to put him in his place. Yeah.
Which, by the way, that computational fluid dynamics, a lot of the state-of-the-art stuff was developed by NASA. Yeah. Remember, the first day is aeronautics.
Boy, and that would be a merit badge and a half, wouldn't it?
I tell you.
And of course, you can find me at pilebooks.com or at astromagazine.com or nss.org and various other places. Now, remember, you can always drop us a line at twit@twit.tv. We do welcome your comments, suggestions, and ideas, especially if you're saying it nicely. And we will answer each and every letter. New episodes of the podcast publish every Friday on your favorite podcatcher, so make sure to subscribe, like, tell your friends, and give us reviews. And hats off to John. 5 stars, will take whatever you got. Don't forget, we are counting on you to join Club Twit, which has reinstated annual memberships because it's just the right thing to do, and it keeps us on the air, which is something that makes us happy, and bringing you horrid space jokes and great guests. $7 a month. You can't beat it for $7 a month. You can also follow the Twit Tech Podcast Network at Twit on Twitter and on Facebook at twit.tv on Instagram. John, thank you very much for joining us today. It has been an absolute pleasure, and I hope we get to talk to you again.
My pleasure, and may you live long and prosper.
Yes.
For quick tech insights, dive into Twit's short form lineup. From hands-on Mac, you can get helpful tips, great apps, and awesome accessories for your Mac, iPad, and iPhone. Hands-on Windows offers essential advice and everything new in Windows. Hands-on Tech zooms in on a specific theme with easy-to-follow advice that turns tech troubles into triumphs. Home Theater Geeks with Scott Wilkinson supercharges all things home entertainment. And if you like watching the shows, join Club Twit and you'll get full video access too, plus ad-free versions and more. Get informed fast with all of twit.tv's short-form shows. Download and subscribe today on your favorite podcast player.